Alright, so our chapter we're doing today is we want to focus on databases mostly. So this is our overview. First words, warehousing. Have you heard about a data warehouse? Not, all right. Okay, so I think we will do that now. Oh, it's gonna help. All right, so yes, we're gonna look at basically these terms. Data warehouse is important. Data mining is important. Collecting data, there's some things we need to remember when collecting data. So maybe before we go on, what is data again? Between data and information, what's the difference? All right, so it's the other way around. Yeah, so data is unprocessed facts, and then information is processed data. So an example for data would be like, let's say we've got all the ages in your class, all those ages or all the maths marks. That would be data. But the information would be the average. What is the average age or the average mark? Or so once we sort of do statistics on the data, then you get information. But the data itself is just like those raw, what to say, values. And that's where a database comes in. If you look at a database, like for your school, it would be all the names and surnames and telephone numbers of all the students. So that all is data. Information from there would be if we worked out what is the average age, or where does most people stay, or um, what is how many boys, how many girls. So once you start doing those things, that those answers are information. But the data is just that all that information that needs to be stored somewhere. And that's where we get a database from. So a database is a place where we can store all these data and to extract it a bit easier. So we get DBMS, database management software. So that is stuff like Microsoft Access is the one that you know. But there's a lot. MySQL, SQLite, SQL Server, Oracle. There's actually many DBMS software that's there. So DBMS is basically software that will just help us work with databases. So like Microsoft Access, there's a lot of features that you can easily create tables and reports and queries and all those things. So it's software that just helps us to work with the database itself. Right, so that's data and DBMS software. Right, so when we collect data, you can do it with forms, and then you've got checkboxes, combo boxes, spinners. So these are all the GUIs that we basically have in our program. That's not important at all. We do get tags or RFID cards. RFID cards is like this, when you can tap and go in, and then what this machine does, it actually records like who entered at what time. So all that information actually gets saved to use at the later stage. Maybe they want to see what time everybody signed in, and so that is your RFID cards. Tags are very similar to that. Um, so you'll see there, so they say they use RFID for maybe products in warehouses, tools in workshops, people going tickets for transport, products sold in a shop. E-tolls, you get that fast lane when people with a tag, or the cars with a tag, can go in that fast lane. They basically just drive through because they've got a RFID tag that gets picked up and then sort of automatically pulls them. So they don't need to stop by the toll gate to do that. So that everything helps to speed up information gathering and all of that. E-tolls in Johannesburg does the same thing. Not 100% because not all cars has got. So what e-tolls have, they've got cameras as well that would record the number plates for the people that don't have these RFID tags. But when they tried a few years back, they really tried to push it a lot where where you buy the e-tag because it made their life easier, that you loaded money and then as you drove through, it actually took off money like a prepaid system. But all that has got is basically RFID tags that just controls the information gathering. We also get digital sensors. Easiest one with this is sort of like your alarm system at home. All those tags could maybe, when something moves or whatever, then it will pick up. Maybe if you've got a CCTV camera system at home, those things could also be. Or then, like a lot of farms, they might have temperature sensors and humidity sensors to sense how it's going with the plants and when they should maybe water more. And so all these things they mentioned is just easy ways to gather information that we then can use to create information with. So we gather the data so that we can create information from that. So you can see what is the average rainfall and what's the average amount of cars that goes through a certain toll road, and. An important word that pops up every now and again is this invisible online data collection. So database is especially important on websites where users create content like YouTube and Facebook and Wikipedia. As been possible for data capture to add information manually. Instead, these websites are set up so that any information entered by users are automatically stored in different databases. This includes items like the status updates, likes, tweets, and any videos or pictures the users uploaded. The databases on the computer's phones are stored. The user's personal information, such as their email address, username, and password. And then they go on. I just want to see where they actually focus on. Um, but what they didn't actually explain it nicely here now. But the thing about the invisible data collection, that is the part where information is gathered that you don't actually know that it's being gathered. So, like in this case, if you go to YouTube, Facebook, Wikipedia, let's take Facebook for example. If you go in there, I think you sort of know because you created an account that it's going to store stuff like your email and your username and password. That will be stored. And you sort of know that. So that is not invisible. But what you might not know is that what they also do is they also store stuff like your status updates to see when you do certain things. What are your likes and your tweets and the videos and pictures that you upload? So they are actually also keeping or gathering that information. And that is sometimes that you don't know that they even check that. Sometimes they'll even gather information like when do you go online? So they would know that, hey, this person is always online between these hours and these hours at night. And they can actually sell that information to other companies to then see like if it's something specific for that type of user. Some companies would say most of their clients are awake, let's say in the early hours of the morning. So they could ask Facebook, all right, can you give us a list of all the people that are actually posting at those hours? And then they'll pay Facebook to actually get that. So, and that is the invisible data capturing, that they're actually capturing other data that you don't even know that is important. And yeah, yes. Yeah, so there's two ways. So this part, when you create a Facebook account, there's a place where you actually have to scroll down and accept the agreement. It's actually in there. So everybody with Facebook accounts, you actually agree to that. So that wasn't his problem. His problem was, like myself, I don't have a Facebook account. So you won't find me there. But my wife does. So if my wife goes online and she takes a picture of us as a family, which includes me, saying, oh, we're by the sea today. Now, if and then they might tag, say, a Francois Cronje at the Sea today. Now, what Facebook didn't think of was that if they sell that information, they're selling my information as well of where I was at that stage. And I never signed any rights. And that's why they were called into court, because the people that's users of Facebook, they agreed to it. Even though they didn't know, but for you to have that account, you had to accept to their legal stuff. So you agreed to that. But the people that doesn't have accounts, but then also gets tagged in, like by the on the side, they never agreed. And that's where Facebook got the problem from. Because then all those people sort of could sue them because they never had the right to sell our information. And that's, yeah. And I think that's probably how they resolved it. I think if they couldn't resolve it, then Facebook would have closed down. So I do think they somehow then got that route, that they first maybe scan everything that is sent, that is only users stuff. Because I mean, Facebook is still up and running and all good. So even after that lawsuit. So I assume they got, somehow they just changed their algorithms to make sure that it's only legal stuff that is sold. So, and then it's legal actually. And that's the problem with those that, the end user license agreement, that EULA, that you guys, just before you install the software, you actually get that and you agree to it just to get the software, and you never actually know what you agree to. Very few people actually read that. I don't know if you read it. Did you read it when you created your account? And that's the problem. Nobody ever reads it, but there you actually agreed that all of your information could be sold to Facebook or any of their, I want to say, subsidiaries or, yeah, friend companies type of thing. So they can actually give out your information because you agreed to it. Um, then you also get this transaction tracking. So this is happening much more now. Even like checkers, with the checkers extra saving card. Do you think, why did they give out that card? I mean, clicks and pick and pay is sort of straightforward because if you've got the card, you'll get like money back and all that. But why does checkers have one? And why does everybody have that card even though you don't get any money back? Because they are recording what you are buying and where. So for you getting that card, and every time you shop and you have to swipe that card, they are actually gathering information on your spending habits. So they use it for a lot of things. Checkers just for themselves sort of can keep track what people buys from which store, how frequently, and what do they buy, so that they can make sure they've got the right stock, and they can look at patterns, how frequently, which days of the month, which hours of the day do you go shopping, and then they use that to sort of work out. Maybe they'll now, after having this a bit, they'll realize that maybe in the afternoons they will double their amount of employees that works on the tellers, and in the mornings they could have it half because everybody's at work and can't shop and stuff like that. But then that they can also sell. They can also use that to say to Cadbury's, hey, look how many clients we've got, all of them are buying your chocolates. Don't you want to give us a discount so that we can even run promotions on your chocolates, because look how many people we've got buying your chocolates from us. So, and that is, this is also part of that the invisible data capturing, because now it's capturing stuff that you don't know is being collected, but it is actually, and that is being used for, I wouldn't say bad purposes, but sometimes if you don't want your information to go out, then it's sort of bad for you, because more people learn more about you, even though you're just a number, but they sort of know who's doing what, where, and those things. And the same with the location-based data. Nowadays, even if you take a photo on your phone, if you've got the right software, you can actually inspect, and that photo actually stores, so the word is metadata, so it's like data about data, and there'd be information in there where the photo was taken, when was it taken, on which phone was it taken. So it actually stores location, time, all of those things, device information about that picture onto the picture. And again, that is information that's being gathered that you didn't know about, but it is actually being gathered. So all of those things, yeah. Okay, then it doesn't. Then it wouldn't. But most people just leave it on. I'm one of those people. It's too much effort to put it on and off when, so I just leave it on because for me, why not? But yes, if it's not on, then it wouldn't. So, but it would try to. If it is on, it will use it. Yeah. And that's all I talk about that. All right, data warehousing. This is also important. Now, if you think of a warehouse, do you agree a warehouse is just a place where you store like a lot of stuff? And so what a data warehouse is, that is basically where we'll store a lot of data. So generally, a data warehouse, I want to say, is like a storage place for old databases. Let's see what they say here. So data warehousing is similar to how factories and distribution companies store their products in a warehouse in real life. It is a technique for storing data from more than one database. Unlike most databases where the data is normalized and stored in the most efficient manner, a data warehouse takes the data from these databases and stores them in a non-normalized way. So what data a data warehouse generally is, that would be, I want to say, let's say the Department of Education. They will have a data warehouse where, let's say, all the old information, so previous, it won't be current stuff. So it will be all databases from the schools are stored. So KZN DBE could have a database warehouse where from, let's say, 2020, from 2015 to 2020, so that stage, all the schools, their databases, that information is stored in a data warehouse for them. And that sort of works. So it works with different databases. Um, as I said, generally it won't be recent. So it won't be like the database the schools are running with now. It would be previous years. So even Richards Bay, let's say your school for the past 5 years, excluding this year, that databases are being stored somewhere with all of the other high schools in the area would be stored somewhere, and that would be a data warehouse. So stuff we do with that. The other important, so there are redundancies, and I think we'll talk now about it, but redundancies means there will be overlapping of information. So it might be, let's say one student, let's like Radia, she'll be in a database for her school, but she'll also be in a database for her school. So her information would sort of be duplicated here because it's got both schools' databases in one place. So now you get duplicates where people moved. So the same student might be occurring 2 or 3 times if they visited 3 different schools in that time. So that's where the redundancies comes in, where you could have duplicates of information, but that's fine. A data warehouse, they don't care about this. They sort of just want to store all of the data they've got. And then what they do is, the important word from there is data mining. And I think that's the next chapter we'll do. So we'll talk about it there. But so let's look. So differences, a data warehouse versus a database. A data warehouse stores a large quantity of historical data and all the data from various databases, while a database stores current transactions and enable easy access to specific transactions. So that's the difference. The important words here, data warehouse, large quantity. So large quantity is important of historical data from various databases. That's your 3 keywords that you need to go with a data warehouse. And then a normal database is current transactions of the specific business and how it is currently running. And that's basically the difference between them. So then you think, but why do we want to actually store all of this, I want to say random data of different schools in one place? Why would they want that? And then what that is called, however, that is called big data. So just see the word big data. So big data just means a lot of data, and a lot of data is stored in a data warehouse. So we call that big data. And what we do with that is data mining. So it's a process to identify trends and patterns between the different databases. So what they can do there is they can say, okay, let's look at what's happening in Richards Bay. Then they'll say, okay, over the past 5 years, let's look what happened to the high schools. Then they can look at um, from, let's say, 2018 to 2023. Then they'll maybe look at how many boys enrolled in grade 8 and how many matriculated, how many girls enrolled and matriculated. And they'll say, okay, they saw there's many more girls that is succeeding. So that means girls are more academically inclined or whatever. Or they'll say the amount of boys increased. In 2018, there was only 10,000 and now there's 20,000. However, girls was 5,000 and there's still 5,000. So they could see, okay, yeah, so the boys actually increased. So, and that's what data mining does. So it sort of looks at all this data and it sort of looks, all right, let's make sense of this. What happened? What is increasing? What's decreasing? What trends are there? Can we see a pattern emerging? Can we see every second year there's a bigger jump in entries? Or every third year it reduces by half? And then they can sort of anticipate, okay, so this year it means it was a small year, which it was, but the next year it's going to be a bump up again. And then it knows, okay, for our schools, we need to make sure that we can cater for this most probable increase in intake in grade 8s and stuff like that. So that is the data mining part. Because if you think of big data, it's just too much data. So we need to make it information. And data mining gets us the information. So data mining will go into a data warehouse where there's big data, and we'll actually look through that and see, all right, what is useful in here. And then it will make stuff like that for us. All right. And then, so that's keywords. So data warehouse, data mining, big data, important words. Invisible data, also I love that. All right, data mining process. This pops out every now and again. So step one, you just extract the data. So get the data out of the database. Then you look for the patterns. And then you discover knowledge from the patterns. So it's relatively easy. So extract the data. So get all the data. Get how many boys and girls there were. Look for the pattern. Then we see through all the years what happened to the amount of boys, what happened to the amount of girls. And then our knowledge is there's many more girls than boys currently. So, and it's just increasing. So something happening, more girls is being entered into school than boys. Right, then we can extract the relevant data. That's what we just talked about. Look for the patterns and discovering the knowledge. That's just the 3 steps of data mining. All right. Caring for and managing data. So the value of data and metadata. So here's the metadata. So that's the information, I want to say the data about data. So that is the who did it, when did they, and stuff like that. All right, let's see. All right, these parts. So yeah, if you can highlight, I would highlight this section. The following 5 characteristics of quality data. They love this. This comes out very frequently. Sometimes they don't ask for the 5, but they'll say, please explain 1 of them, or explain 2 of them, or they'll ask name 3 of them. But this generally pops out quite frequently. So, characteristics of quality data. So, what makes data like quality, a high quality? Firstly, it must be accurate. So that means it must be correct and precise. You can't just have ranges and stuff. You must know exactly this is what is there. It needs to be consistent. So in one part of the database should not contradict another part. So you should not have one part of the database, I want to say like where, let's say a person stays in Richards Bay and then you look another part, then it says no, he stays in Empangeni or whatever. So it needs to be consistent. One piece should not contradict the other piece. It should be current. So it must be stuff that's happening now, up to date. Shouldn't be last week or last year's information. It should be current, up to date. It must be complete. You must have all the information in there. I can't have information with, let's say, the data for your, like the students in the school, but then you don't know the telephone numbers of some and you don't know the addresses for others, and then you sort of, you can't work with that. So it needs to be complete. You need to know all the information for everything, and it needs to be relevant. So, like for your school, you want to know um, name, surname, telephone number, and stuff of parents and all that. But like if your school saved the shoe size of each student, it's sort of not relevant. Why do they want to know the shoe size? Or your favorite color for each student? Like, why? So that's the relevant part. It should be relevant to the company and what they save the data for. So these 5 keywords you need to sort of remember. That is for quality data. Right. Then protecting of data. So yes, they can. They can. And they'll probably ask it with a scenario. So they'll ask you maybe, let's choose something else. Let's say doctors. There's a doctor with a database. And can you give an example of, let's say, 2 characteristics and examples from a doctor's firm? Then you can say accurate, meaning that in the doctor's database, you want to know like the person's blood type and maybe his weight and height. That should be exactly correct. You can't just say, uh, if you take an adult, you just say, yeah, it's over 20 kgs. I mean, it's not accurate enough. It needs to be consistent. So having the telephone number for a patient should be the contact number in the one part should be the same as the contact number in the other one. Current, it means it must be your clients that you've got now, the patients you've got now. It's not going to help if you don't have your current patients listed there. A database won't be useful if, let's say, all your current patients you use physical files and then just all the old people you put in the database. Then it's not current anymore. It needs to be complete. So you should have all your patients there. It's not going to help if you ask your secretary, please get me John's information. And then she says, oh, John is not in the database. I mean, why not? It's not complete. And it must be relevant. So the information on there, we should not have um, hobbies and stuff like that in a doctor's firm for their patients, for argument's sake. So it should be information that is relevant to them, blood types, weight, height, previous conditions, stuff like that. So yeah, then you sort of just think around the scenario and make it fit. But yes, they can ask for that. All right. Yes. Yeah. Generally, it's if you sort of remember the words, I want to say it's a closer to a English comprehension test than it's actually a IT test. If you understand these words, then you must sort of just apply it to that. So you must just think of an essay that you need to write about this in a one sentence type of thing. Just creatively think about the scenario and how this could fit. All right, then these 8 tools and techniques are also important when you want to protect the database or the data in a database. Data validation verification, very important. We're going to go through that now. integrity checks, logging changes, data warehousing, access control, parallel data sets. So all this is to protect our data from loss, or you'll see there, from accidental deletion, purposeful deletion, unauthorized access, data loss, corruption, to just lose it either by mistake or somebody that's trying to steal it from us. So data validation, I want to say, put a note for yourself here. Data validation is the part where you actually check that, I want to say, you can do this with coding. So that would be the part, let's say, if we do at your high school, you do entries for grade 8. You can sort of check when the person type in his age, that the age must be more than 12. Because you won't have, or more than 11, let's say. Because you won't get a person younger than 11 that's going to enter as a grade 8 student. And you can also say the age should be less than 21, because you're not going to have a new student coming into school that's older than 21. So that is data validation. You can put stuff like that on to make sure that the data that's entered is correct. So data validation, there's different checks, like what we did now. We did a range check. We check that the age is between 11 and 21. You can do also a data type check to make sure that when the person types in the age, then it's only a number. You can do a also like a data type check with maybe the gender to make sure it's only M1F and stuff like that. So all that is validation. When the person types in the information in, that we make sure it is most probably correct. Remember, we've got that abbreviation as well, GIGO, garbage in, garbage out. So if the guy enters garbage into our program, our output will also be garbage. Like if I asked your class, let's say I want to do a poll and I wanted to see what the average age is, and I ask you guys, please enter your ages. And then everybody thinks they're funny and they say, I'm 5 years old, and the other guy says he's 95, and the other one says he's 12, and the other one says he's 77. Then at the end, my average age for your class would be completely wrong, because the information I got in was rubbish. So then my result will also be rubbish, and that's the garbage in, garbage out. And validation could help us with that. Verification, though, that can only happen, I want to say, in person. So that is if a person, let's say we had John here, or just Jay Smith, and he said he's male. I can't necessarily know that he's lying or not, but let's say we get the person and we ask him, hey, Mr. J. Smith, are you really male? And he says, oh no, I'm actually Jane Smith. She's actually a girl. Then so, and that's the verification where obviously you sort of ask the person, is this really the right thing? Integrity checks, that is to make sure that nobody fiddled with the data. It's like when somebody entered the data today, that the janitor can't go at night and go add some stuff to the database and stuff. That is the integrity part. That only authorized people have got permission to add and remove stuff from the database. Logging changes, that is keeping a log for everybody that makes changes to the database so that you can know, all right, tonight at 6 o'clock, this person came in and he made a change to the database. The next morning at 7 o'clock, this person came in and he made a change to the database. So you sort of want to just keep track of who made changes when to the database. Data warehousing. So just keep backup data. You know, this is our old data. We keep it just there for safety's sake. Access control. Make sure that you lock the office. There where the database is. Make sure it's locked. Make sure there's an alarm system. That anybody can't just walk in and either delete the data or steal the data or change the data. So that is like physical access control, but also digital, having usernames and passwords to make sure that only the right people has got access to the data. And in parallel data sets, parallel goes side by side. So that is sort of saying that you'll have two databases with the same data on. And when you change on the one, it will change on the other one. The benefit is if the one crashes, then you have the other one as a backup. So that would help for like this accidental deletions and stuff like that, where you could, or data that becomes corrupt. So the parallel data sets, because you've got two sets of information, if the one, something happens to the one, the other one will be a backup. And now, yes, um, let's see. It's good to know some of them. A range check is easy, and format type is easy, and then there's what is the other? A presence check as well. And presence check. Presence check means that you actually enter something, so you can't leave it open. That's for like a primary key. That you force the person, he must enter this information. It's a presence check. So yes, know them as well. No, it's virtual. It's a server basically. It's a server somewhere where it just stores all the data. So no, yeah, so it's not a physical, well, yeah, it's a physical server, but it doesn't need to be a big room. It could literally be just a server running all of that stuff. All right, then you'll see here they sort of explain everything. There's a data validation and the verification, integrity checks, logging of changes, and then they talk about an audit trail. So that goes with the logging. So audit trail is who made the changes, what changes was made, when did they make the changes. And then they talk about our database warehouse, talk about our access control. Yes. So audit trail, that's our logging one. So that is, let's say information got lost. Then you can go look and you can see, oh, I saw last night at 6 o'clock, person X came into the office and changed the database. So now you know person X is the person responsible for the information that's lost now. So then you can either I don't know, fine him or send him to jail, depending on what he did, obviously, or just fire him. But then you sort of know who did what when, and you can sort of track for that possible. Um, so it will discourage other people as well from sabotaging the database because they know you will know who did it. So then they won't actually do it. And if they do it, you'll know who did it, and then you can just fire them, and then it won't happen again. So there's a lot of things actually. If you think about some companies, I mean, for Ford and Toyota, if Ford can sabotage Toyota's one, that would mean everybody will be unhappy with Toyota. Imagine people wanting now to go service their cars or check warranties, and now Toyota said, "Hey, sorry, we lost all our information. We don't know what." So it could cost them a lot of money to actually try and recover. You won't know whose warranties are working when. So firstly, you'll lose all the clients. Clients won't be happy, or you'll have to extend everybody's warranty, and that would cost you a lot of money. So it can actually cost a lot of money, and some company would want to do it to another one to give them the edge over that one. Yes, similar to that, but it could also just be a disgruntled employee. Let's say at your school, a teacher gets fired for doing something wrong, but then he feels no, the school is at fault, and then he just goes onto the database and deletes everything. All the students' information, all the billing information. Now suddenly the school doesn't know who paid what when and who's owing what where, and that would be chaos. It would be a big problem for the school. So and that so it could be disgruntled employees. It could be just corporate espionage. Any of those things it could be, or it could be just hackers. You know, you get the hackers that just wants to prove something. Yeah. All right, then our data warehouse. We spoke about that. Then we've got our access control. We can have passwords, user rights, just good security overall. Parallel data sets, we spoke about that. We keep basically a backup. So duplicate set of data. Yeah, that's that one. So you do want to know, so some of it might come out now, but also what you need to know is like what is a primary key? You know what a primary key is? Yes, that uniquely identifies each record. Yes, perfect. Perfect definition. Um, so I want to say sort of that is mainly all. Um, you need to, yes, so you need to know that also, yeah. It's just those keywords. In this, you'll see now what we add here now is you get a flat database and a relational database. Relational just means the tables inside are linked with each other. So the two tables, you remember like we've always, well, in our examples, we've always got that field that's in both tables that links them together. That makes them a relational database. If you had two tables that was completely unrelated to each other, then it would be a flat database. Um, yeah. Generally, we won't see a lot of flat databases. Every time we'll see the relational one because that's what we're using in our pets and that's what you work with most of the time. Then you know what is a field again? Yeah, so it's just like single data type as well, and a field's a column. So it will be a single type of data from all the records that it's storing, and then a record is like each row. So it has to do with one object and all the information of one object. We get our compulsory fields, which are our primary key that we spoke about, which is our unique identifier. See, so it's sort of covering that again, the stuff that we did. Um, right. All right, so characteristics of a good database is, and then this looks sort of similar, but then these yellow words are also important. So of a good database, the characteristics of a good database is our data integrity. So the data shouldn't be accessed by anybody. It should be protected. Data independence, that means the database can work on its own. It doesn't need to be, it shouldn't be able to work only with one type of program on one machine. It should be independent from all the programs that access it. Data redundancy, so we don't want that. Redundancy is duplicate data. So you don't want data to be repeated in multiple tables. You want good data security and you want good data maintenance. Just on a monthly or hourly or whatever basis to check that the database is free of errors and works good. These things generally just need to list them. Alright, then different people that work on a database. I think you can just read through that. It's very straightforward. Alright, this is important though. Problems with databases. So there's three types of anomalies. I love asking this. So you get insert, delete, and update anomaly. So you can say update anomaly or modification, same thing. So anomaly is another word for error, I want to say. So it's a mistake that can happen in a database. So if they talk about errors in a database or stuff like that, then we're talking actually about anomalies. If I ask you what three types of errors can occur in a database, then you'll tell me insert anomaly, delete anomaly, or update anomaly. How they work. So an insert anomaly. The problem is there is when you want to add stuff to a database, but you can't. So an example of that, let's say we've got a program or database for a hospital, and it is set up in such a way that the primary key is the doctor's ID and the patient's ID. So we made that the primary key is both of those, a composite key. So that like any patient, you'll know who the patient is and who's the doctor treating that patient. But now let's say you get a patient in the emergency room, or he just arrives there, and now he says he wants to enter the hospital, but he doesn't have a doctor yet. And now the people tell them, listen, we can't put you on the system because you must have a doctor. So we can't add him because he doesn't have a doctor yet, but he can't have a doctor because he's not entered into the hospital yet. So it's sort of that, I don't know, what came first, chicken or the egg type of thing. So there's no good solution to this, and that is an insert anomaly. So we can't add the record because they say it doesn't comply with the full primary key, but we needed to add. So you want to add a record, but it's only the person, and we needed the doctor as well, but it doesn't get the doctor because he needs to be entered first. And then that is the problem. All right, insert, good. The delete one is if you delete information, then other related data also gets deleted. So let me just see if I've got a nice example here. Okay, not so much, but okay, let's stick with our doctor one here, our doctor patient. So let's say we had the patient's name, surname, all the patient's details, and then next to that we're carrying on and we've got all the doctor's detail, this doctor and that, all the information of the doctor. But the doctor only has this one patient. Now that patient leaves and they say remove the patient from the database. So as soon as you remove the patient, then suddenly the doctor also gets removed because it's in one line. So now the doctor technically also gets removed just because the patient gets removed, or vice versa, because they're in one line. And that is a delete anomaly. When you want to delete one part of information, but by deleting that, you're actually removing other related data as well that you didn't want deleted. And that is our delete anomaly. And then a modification or update anomaly is when you want to update something, but you have to update it in many places. So I can maybe use this example. Let's say the balance depends on the country, on the address. So now they said, all right, Cape Town's new amount is 500 Rand. So now I have to change the 500 Rand there, and there, and there, and there. And that's an update anomaly. So that when one piece of information needs to be changed, but now you need to change it in multiple locations to actually affect the change. And that is an update anomaly. So they can give you a scenario and ask you what type of anomaly. That would generally be easy because you read the question. If they're trying to add something and they can't, then it's an insert one. If they're trying to delete something and it deletes more information, then it's a delete anomaly. And if you want to change some information, but by changing it, you need to change it in many different locations, then it's an update anomaly. So if they give you that scenario and ask you, that's an easier question. Sometimes they could give you a scenario and explain how these anomalies occur in this scenario. And then you would just try to think of that definitions I just said. So you want to add something, you want to add a record, but you can't because you don't have the full primary key. So that's generally with a composite key that your insert anomaly occurs. And then your delete one is you trying to delete a record, but because you're deleting that one, you're losing other information as well that you didn't want to delete. And then a modification one is you want to change some data, but to change it, you have to change it in multiple places. And that is the update anomalies problem or mistake. All right, Then here is some more examples that you can read through just to try and understand. What I will do, I'll give you an activity also on this so that we can just practice in nicely. Alright, then how can we get rid of these anomalies? And the easy way with that is with normalization. So normalization is the process to basically create an efficient database by removing anomalies and removing our redundancies so that we don't have all these additional. So eliminate data redundancy and these anomalies. That's why we've got normalization. So we want to remove those things. Right. Okay, some words that you should know about. Atomic. Atomic data is data that's only got one value. So let's say we've got in our database, we've got a address field. But in the address field, you've got a street number, a street name, a town, and a postal code. So there's actually 4 things that's in one column. So that is non-atomic. And you don't actually want that. You want atomic fields. So you actually want to break up your database so that a building number is alone, street name is alone, suburbs alone, town is alone, and postal code is alone. Then it becomes atomic data. And then that's fine. Here's our keys again. Primary key we know. Our alternate key is just another field that could be used as a primary key, but it's not. Foreign key, remember that is when our primary key of the one table is in another table. Then we call it the foreign key. That would be the link to the two tables. And a composite key is when it's a combination of more than one field to make up the primary key, basically. When it's not just one field that needs to make the primary key, we call it a composite key. All right. I'm sort of rushing through this, but this is the last piece that we've done here. We're basically finished now. All right, so this last piece you need to know is for normalization. You don't need to worry about how to do this. They won't ask you to normalize. The only thing they'll ask you is to explain the steps. So there's 3 steps. First normal form, it needs to have, let me just see, each column must have a separate field attribute. Let me see if there's a nice definition. Okay, not so much. All right, but with this one, so you should have atomic data. That's basically what this says. So each column should be only have one value in. You should not have duplicates. So you should not have non-atomic fields. Everything should atomic. So like that address example I used, that should be split into 4 different columns to make it better. Like even with this one, you don't want with subject, you don't want math and English, because now there's 2 values inside one column, and that's the wrong thing. So you rather want this in 2 columns or in 2 rows. You need to split it somehow so that English and maths is separate. You don't want them together. And then, oh, you must have a primary key. That's your other rule for this one. So let's just see if there's a nice definition. Not so much. So, but for 1NF, you want atomic fields and you want a primary key to be identified. That is your key things for 1NF to be in first normal form. Then for second normal form, easy thing is it must be in first normal form and there are no partial dependencies. So I want to say just learn that, but a partial dependency has to do with the composite key. Remember, composite key is when we've got a primary key that's actually 2 fields, 2 or more fields. So if you've got a field that relates to only one part of it, then it's a partial dependency because it's only dependent on part of the key. And then our third normal form must be in second normal form, and you should not have transitive dependency. Transitive is when a field is dependent on another field that is not the primary key, then it's a transitive one. So it's similar to this one. However, this one, second normal form with partial dependency, a field is dependent only on half of the key, while with this transitive one, a field is dependent on another field that is not the primary key at all. And then that is a transitive. Yes, let's see. So if we look at this example, if we look at this table, let's see. So you'll see there's sort of duplicates everywhere. You see there's John Smith is twice, telephone number twice, Maths is twice, Peter Botha is twice, the telephone number is twice, marks would be duplicates. So there's no one field that could be a primary key. So most probably what will happen here is we'll say student name with teacher. If we take these two columns, then it's unique. Because John Smith and Siyabonga, if you look at that line, there's no other John Smith and Siyabonga. The other Siyabonga is with Junior, and if you see a John Smith again, it's with a Peter Botha. So a primary key would actually be a composite key between this field and this one. So this would make this, then it's in 1NF, if you say this is a composite key. But now, so we've got two keys. If you look at the student telephone number, do you agree this student telephone number it only has to do with the student name. It's got nothing to do with the teacher. Do you agree? So this student phone is only dependent on the name. So this is a transitive dependency. A partial dependency, sorry. This is for 2NF. It's a partial dependency because student number or student phone is only dependent on half of the key. One of the fields that's a key, it's only dependent on that one, not on both of them. So this is a partial dependency. The same with the teacher phone number. It's only dependent on the teacher. It's got nothing to do with the student. So this is also a partial dependency. And then, but this subject, I want to say, goes with the student and the teacher. So that one's fine. And the marks. Because this marks is what this student got from this teacher. They got these marks. So these marks are dependent on both of them. So this is a partial dependency. The transitive one, if we take my example of the address, do you agree? If you know what the town is, would you be able to know what the code is? Yes, so let's assume there's two more columns here. There's a town where the student stays and the code where the student stays. Then that town is dependent on the code. It's got nothing to do actually with the student or the teacher. It's just literally the code and the town, they are dependent on each other. Because if you know the one, you'll get the other one. So that is a transitive dependency. That is now two fields that's dependent on each other. That's got nothing to do with the actual primary keys. And that's a transitive dependency. So knowing that the ERD, entity relational diagram, ERD diagram is important. You need to know that one-to-many or many-to-many or one-to-one relationship between tables and how to draw them with a crow's foot. And then they like asking for the verb that you'll say, like one teacher has a lot of students. So you have the has a relationship. If you go from left to right, one teacher has a lot of students, but then so it depends how the scenario is phrased. But then you can say a lot of students will only have one educator. If you think of a primary school where everybody's in one class, they'll only have that one teacher. So yes, ERD diagrams you also need to know.